Hi everyone, welcome to the Verilog HCL crash course. The motivation behind this course is to cover each and every important concept related to Verilog HCL, which are very important from VLSI interview perspective. So here we will be covering almost every concept related to Verilog HCL with proper examples. The target audience for this course would be VLSI fresher students as well as the professionals who are in their early career stage. So let's get started. So in the first module of this course, we will be covering about brief introduction of Verilog HCL, and then we will see different level of abstraction. The meaning of different level of abstraction here is during the IC design, at what different levels we can do Verilog HCL modeling. Our next module in this course will be on lexical tokens, where we will be covering about white space, comments, numbers, identifiers, operators, and Verilog keywords. So basically in this module, we will be seeing what all tokens are there which will constitute a Verilog HCL code, like white space, comments, identifiers, and Verilog keywords. In the next module, we will be covering about data types, where we will see the value associated with the data and also the data types of some of the Verilog keyword like input, output, or in-out, and we will cover the data types like wire, register, shuffle data type, and time and parameter. In the next module of this course, we will be covering about Verilog operators, where we will be covering different types of Verilog operators like arithmetic operator, bitwise operators, conditional operators, concatenation operator, reduction operator, etc. And in the next module, we will be covering operands. So operands is nothing but the entity on which a particular operation has to be performed. So the example would be literals, which will constitute our strings and numbers, and then we can have wires, register data, parameter, bit select and part select of a particular signal, and function. In the next module, we will be seeing about module declaration, module instantiation, and then how we can write a parameterized module and can instantiate it on top design. And also we will be covering about continuous assignments. Moving further, in our module 7, we will be covering about behavioral modeling, where we will see different concepts in Verilog HCL like procedural assignments, delays, blocking and non-blocking assignments, Verilog keywords like begin and end, Verilog HCL loops like for loops, while loop, forever loop, and then we will also see about if-else, if statements and case statements. Moving further, we will be covering about timing controls in Verilog HCL. So what are all the timing control statements in Verilog HCL and how they work? In this particular timing control module, we will be covering about all those. In the next module, module number 9, we will be covering always and initial blocks. So here we will see what is an always block, what is an initial block, and how we can make use of always and initial block in our Verilog HCL design or test bench code. Then we will be covering our Verilog HCL functions. So here we will see how to declare a function, how to call a function, and how a function returns a value, and then all the rules which are associated with function declaration with proper example. Then we will be covering about task, and here we will see what is task and how it is different from a function and what are all the constraints associated with that task. And moving forward, we will be covering about component interface. So here actually we will be writing some Verilog HCL code, and we will see how a Verilog HCL code infers a digital hardware. For example, how a register is inferred from Verilog HCL, how a counter is inferred, how a multiplexer is inferred, etc. And then we will be covering about finite state machines. Here we will see different types of finite state machine and how we can implement finite state machines using Verilog HCL. We will see some example of counters and shift register in this module. And then we will be covering about memories. So here we will see how to declare a memory, how to initialize a memory, and how we can make read and write access to a memory. And in our module number 15, we will be covering about compiler directives. Here we will see what are all compiler directives, what a compiler directive is, and how it is useful in Verilog HDL coding. So basically compiler directives are very important in writing an efficient Verilog HDL code. And then we will be covering about system tasks, where we will going through each and every system task. So system task is nothing but some inbuilt Verilog HDL task which we can make use in our Verilog HDL coding, whether it is design or a test plans. So system tasks are basically very helpful in design test plans or in simulating a design. Then we will be covering about test benches, where we will write a test bench for a particular design, and we will also see about synchronous test bench. And then I will cover some of the interview questions which are asked to me during my interview process, and I will then cover some of the frequently asked questions in VLSI interviews, and then I will be providing a Verilog SQL practice question bank. So I hope this particular course is going to be very helpful for you during your interview process. Here each and every modules would be an average of 10 minutes long, and that will constitute a total of 200 minutes. That means 3 hours and 20 minutes course. So believe me, these 3 hours and 20 minutes are going to be very useful in building your Verilog SQL concepts. See you soon in the first module of this Verilog SQL crash course. Thank you very much.